Welcome to Algebra 2 at Temple City High School. This is 3.3 using linear programming. It's also called linear optimization because we're going to be looking at lines and graphing them and then finding the vertices of the polygon that we create. All right, what we have is a farmer can plant up to 8 acres of land. Oh, by the way, linear programming or optimization, what you're trying to do is you're trying to either maximize something good like profit for a company, or you want to minimize something bad like costs, and through a linear optimization you can do that, and that's what we're going to do. We're going to be drawing some lines and then seeing where they intersect, and those are going to be the vertices. We're going to check each of those vertices to see which one either maximizes or minimizes the optimization formula. So what we're trying to do is either maximize the profit or minimize the costs in the objective function, it's called. So you're going to have one objective function, but then you're going to have some constraints. For example, in production, you can't hire an employee and have them work 90 hours. There's a constraint there. You can only have them work so many hours. So we're going to try to minimize or maximize the objective based on one of the vertices. We're going to check all the vertices and see which one gives us either the minimum amount or maximum amount. If the feasible region is fully bounded, both minimum and maximum values will exist. So you're going to see how this works. So example 1, we have a farmer. He has 8 acres of land and he wants to plant barley and wheat. Do you have a constraint here? Yeah, he's only got what? 8 acres, yeah. So this is called a constraint. And he's got a total of 8 acres. So he can plant barley and he can plant wheat. So B is going to stand for what? Yeah, the number of barley acres, and W stands for the number of wheat acres. Yeah. So we have B plus W, and there's a constraint. What can that be? 8. Ah, very good. It's less than or equal to 8. Can't be more than 8. So there's a constraint there. The second item. He profits $3,000 for every acre he plants with barley, and $5,000 for every acre he plants with wheat. So this comes back to one of the first things we talked about was how many you have times the value of each. So he gets $3,000 for every what acre? Barley acre. Let's go back. His profit's going to be $3,000 per acre of barley. So this is the value of each barley acre, and this is the number of barley acres. His profit's going to be 3,000 B plus what? 5,000 W. Nice job. And that's going to be his profit. He's going to want to what his profit? Maximize it, yeah. So this is going to be called the objective function because his profit's going to be equal to 3,000 times B plus 5,000 times W. Now, right now, what should the farmer do if we only have those two items? Plant all wheat, yeah. Let's go 8 acres of wheat and you made 40,000 bucks. But in real life, there's other constraints. For example, what I said was you have so many workers, they can only work so many hours, or there might be some laws that constrain you. So that's what we're going to look at right here. His use of necessary pesticide is limited by federal government. Oops, it's a limit, it's a constraint, to 10 gallons for his entire 8 acres. So keep that in mind. And the barley requires 1 gallon of pesticide for every acre, whereas his wheat requires 2 gallons per acre. So let's go ahead and figure out the pesticide that he needs. And it's equal to how much? What's the value of each? Barley. 1 gallon per acre. How many acres? B, good. And he's got to add on the wheat pesticide. 2W, yeah. So do you see the conflict now? Because if he plants all 8 acres of wheat, he's got how many gallons of pesticide? 16, and he went over the limit, so there'll probably be some fines involved here. So there's a constraint here. Is the necessary pesticide is limited to 10 gallons? Is that a constraint or an objective? Constraint, yeah. Yes. Good question. His use of pesticide is limited. It's a constraint. He can't use as much as he wants. Our objective for this whole problem is to maximize profit. Oh, hey, great question. 1B plus 2W better be what? Less than or equal to what? 10. Ah, so these actually go together. Great question, Jason. Thank you. So together, that is one constraint there. And now we can go to E. The farmer must plant at least 1 acre of wheat to maintain favorable tax status. So what is that? It's a constraint, and what has to be what? W greater than or equal to 1, yeah. The number of wheat acres has to be at least 1, greater than or equal to 1. So the question is, what's his maximum profit and what's his minimum profit he can make? Let's go ahead and do A. I'll put that in purple here. And that is B plus W is less than or equal to 8. So we're going to graph that. And this is actually the barley on the horizontal axis. So there's our 8 right there. And then the wheat is also 8. So we're going to graph that. Now the question is, which way are we going to shade, up or down? Down, yeah, because he can't plant more than 8 acres. Let's go to the next constraint. He can only use 10 gallons of pesticide. So that's C and D here. So what's the B intercept here? This is for barley. For barley, it's what? 10. And for wheat, it's 5, okay? So we got a slope of -1/2. Are we shading above or below? Below. 5. The W-intercept is 5 because we're comparing it to 10 right here. Put 0 in for B and you get 2 times 5 is less than or equal to 10. You can see is you do have a vertex right there, which we'll get to in a second. The farmer must plant at least 1 acre of wheat. What kind of line? Horizontal or vertical? Horizontal. This has to be at least 1. And is it up or down? Up, yeah, up here. So notice we have another vertex right here. And obviously, he can't plant how many acres? More than 8 or less than what? 0, yeah, okay. So let's go ahead and put the constraints in. We got 0 at this end and 0 at that end. This one's a moot point because it's not necessary because you already have 1 acre of wheat you have to plant. So, okay, let's find the vertices that are critical. There's this one, and this one, and this one, and this one. Let's label these as J, K, L, M. So what are the coordinates of J? 0, 1, and K, 0, 5, and L, 6, 2, and M, 7, 1. Okay, now, what's your guess? Which one do you think is going to maximize profit? J, K, L, or M? L, that's your guess for maximizing. And which one do you think is going to minimize profit? J, okay. All right, let's check this out. This is 0 and 1, so you've got $5,000 here. And 0, 5, you get $25,000 here. 18,000 plus 10,000 is 28,000, and finally 21,000 and 5,000 is 26,000. And you guys nailed it. This was the maximum profit, and this was the minimum profit. So isn't it ironic? Originally we thought, hey, we earn $5,000 for every wheat acre. Let's plant as much wheat as we can. Let's try 8. Oh, wait a minute. There's a problem. There's the pesticide. That takes up 2 gallons of pesticide out of the 10 that were allowed. So as you can see, it's not even close to 8. It's only 2 acres of wheat and 6 acres of barley. So what's the maximum profit he can make? 28,000 with 6 acres barley and 2 acres of wheat. And then the minimum profit is $5,000 with 0 acres of barley and 1 acre of wheat. Comments, questions? Good question. The question is, how do you know what vertices to check? What you do is you shade in the solution set here. There it is. You look at all the constraints and shade within the constraints there. So as you can see that polygon. So you've got this green boundary, you got the brown boundary, you got this little purple one right here, and you got the blue one here. So you shade inside, and then you can see the 4 sides and therefore the 4 vertices. Well, you can't do negative acres. So this was, you can't shade over here. You know, you can't plant negative acres of barley. And below this, you can't shade negative acres. So that is linear optimization.